welcome all of you. Today we have discussed about the introductory part of the spectroscopy. Large number of organic compounds are isolated from their natural sources. Many more compounds are synthesized in the laboratory. But the structure of these unknown compounds is important for the chemists, and determination of structures of these compounds is a challenging task before us. There are various methods used for determination of structure of unknown compound. These all methods are classified into the two categories: chemical methods and the physical methods. Chemical methods include determination of functional groups, preparation of derivatives, qualitative analysis, elemental detection, means detection of the elements other than carbon, hydrogen and oxygen by the Lassigny test, means there is a presence of nitrogen, sulfur in the compound, synthesis in the laboratory. These are all the chemical methods. Now the physical methods are determination of physical constants like melting points and boiling points. Means take a melting or boiling point of the unknown compound and compare with the standard value. Determination of dipole moment and refractive index, these are the instrumental techniques. Determination of molecular weight, X-ray crystallography and spectroscopic methods. From these methods, spectroscopic methods are the best one due to some advantages, such that very small sample is required for determination of the structure of compounds. For example, IR spectroscopy requires 10 mg of samples, and from this less sample is required for the UV spectroscopy. Second one advantages is these spectroscopic methods requires less time for the analysis. Within 5 to 10 minutes we got results, and analysis of these results we got the correct structure of the compound. This method gives more detailed information about the structure. For example, stereochemicals details and extent of conjugations. In spectroscopy, the compound is exposed to certain kinds of radiations, and the responses given by the molecule are recorded in the form of a graph is known as a spectrum. Analysis of spectrum, we can determine the structure of unknown compound. So, the definition of spectroscopy is: spectroscopy is the study of responses of the molecule when it is exposed to certain kinds of radiations. When a molecule is exposed to light radiations, wavelength of radiation absorbs or emitted. Depends on this absorption and emission, there are two types of spectroscopy: absorption spectroscopy and emission spectroscopy. We discuss detail of the absorption spectroscopy. In absorption spectroscopy, absorbed radiations are detected by the detectors and gives a spectrum. Means in all the spectroscopic methods, in absorption spectroscopy, nature of radiation absorbed is studied. Absorption of different types of radiations like UV, visible, infrared produce different kinds of excitations of the molecule. For example, when the molecule is exposed to microwave radiation, it undergo rotational excitations. And when the molecule is exposed to infrared radiation, it undergo vibrational plus rotational excitation. And when the molecule is exposed to UV visible radiations, it undergo electronic excitations along with vibrational and rotational excitations, because UV radiations are high energetics than microwave and infrared. Due to this, UV spectra are broad, because this UV spectroscopy gives electronic, rotational plus vibrational excitation, and these excitations are overlap with each other. Therefore, UV spectra are broad. So, based on the radiation, spectroscopic methods are following types: ultraviolet spectroscopy, UV, infrared spectroscopy, IR, nuclear magnetic resonance spectroscopy (NMR) and mass spectroscopy. Ultraviolet, visible, infrared are the different types of electromagnetic radiations. These electromagnetic radiations have both the properties, wave properties and also the particle properties. They having the different ranges. For example, gamma rays is ranges from 0.2 to 1 angstrom degree, X-rays 1 angstrom degree to 10 angstrom degree, UV rays 180 nanometers to 400 nanometers, visible 400 nanometers to 800 nanometers, near IR 0.8 mu to 2.5 mu, IR 2.5 to 15 mu, far IR 15 mu to 200 mu, microwaves 10 to 5 nanometer to 10 to 7 nanometer, radar waves 10 to 7 nanometer to 10 to 9 nanometer, and radio waves 10 to 10 nanometer to 10 to 11 nanometers. So, according to this electromagnetic spectrum, as we move from right to left, energy goes on increasing, and as we move from left to right, wavelength goes on increasing. So, type of spectroscopy depends upon the wavelength of electromagnetic radiation used for analysis. When organic molecule is exposed to electromagnetic radiations, some energy absorbed by the molecule. Due to absorption of molecule undergo excitation, that is molecule goes from ground state to excited state. Amount of energy absorbed by the compound depends upon the wavelength of electromagnetic radiations and structure of compound. Thank you.